Hi everybody, it's Video Notes 9C Part 2. So we learned about limiting reactants, and now we're going to use limiting reactants and pull it all together with percent yields because we need more cookies. So here's what the whole objective 9C is being able to identify a limiting reactant, then use its mass to determine a theoretical yield, and then use the theoretical yield to calculate a percent yield. So you have to be able to do all of this to do that. So here are some steps you can use. First, decide what is given in the problem and what you are trying to find. I call given G and I call find F. If two reactants are given, you have to find the limiting reactant. Once you do that, or how do you find the limiting reactant? So this is how to find LR. Okay, pick one reactant and change it into the other reactant using the periodic table and mole ratios. Then compare the answer you get from turning one reactant into another and think about what it means. What does it mean? All right, we'll practice. You already did, but we'll practice some more. Once you know the limiting reactant, you use the limiting reactant to find yield, theoretical yield. And so that means turn limiting reactant into product. So yield is always a product. All right, and then use the actual yield and the theoretical yield to find the percent yield, and then you're all set. You know what I mean? Well, let's see. So percent yield. You've seen it before, but now we've talked about it a lot, and we're going to pull it all in. So percent yield is the part over the total. That's any kind of percent. It's always part over total times 100. So what is the part when we're talking about percent yield? Part is what you got in the lab. So it's the actual amount of product that you made in the experiment, okay? So it's what you make or made in an experiment. So say you made a white solid, it's the mass of the white solid you made in the experiment. Okay, that's part. Total goes here. It's what stoichiometry or the calculation says you should get or should make. That's in theory or what you expect. So a theoretical yield is a calculated amount of product. So anytime I say yield, I mean product. Yield means product. And theoretical yield is what you calculate starting with the reactant. Okay, if given two reactant amounts in a problem, the total that goes down here, also known as the theoretical yield, comes from the limiting reactant turned into product. So percent yield is actual yield over theoretical yield times 100. That's what it is, percent yield, actual yield over theoretical yield times 100. Hey, what did you say? What did you say? I said, I got to erase those words off your face there, kid. And I said that percent yield is actual yield divided by theoretical yield times 100. Let's try it. Calculate the percent yield if 550 grams of C7H8 reactant, and 287.3 grams HNO3, another reactant, makes 601.1 grams of p-nitrotoluene product. All right, so we're given two reactants. So this is a limiting reactant problem. Really, we're trying to find percent yield. So we need actual yield over theoretical yield times 100. How do we get an actual yield? It has to be given in the problem. So this is actual yield, 601. So given actual yield is 601.1 grams of C7H7 and O2. Also given reactant 550 grams of C7H8 and 287.3 grams of HNO3. All right, so we're given the actual yields. We have to find the theoretical yield in order to find percent yield. So limiting reactant problem means you take one reactant. You could pick either one. All right, I'm going to pick the 550 grams of C7H8. Notice it's a reactant, right? Reactant. I'm going to change it into product. Now the product that I'm given the actual yield for is C7H7NO2. So I would not use water because the actual yield is given as C7. Well, it's called p-nitrotoluene. So I'm going to take grams of C7H8 and change it into moles of C7H8. The chemical name of C7H8 is called toluene. It's an organic molecule. Yay, organic molecules. C7H8. And I'm going to turn it into moles of C7H7NO2. And then I'm going to turn moles of C7H7NO2 into, whoops, what am I doing? Come on, Harbin, get it together. Okay, so, all right, so it happens. Make mistakes, but then you think about it and you fix it. So, here's what I need to turn my moles of C7H8 into moles of HNO3. Why am I doing that? I'm saying, okay. And then I'll change moles of HNO3 into grams of HNO3. All right, here's what I'm doing. I'm saying 1 mole, and anytime it's moles and grams, I got to go get the grams from the periodic table. So I found out it's 92.15 grams. Right? And then from the coefficients, one of these gives me one of those. 1 mole of C7H8 gives me one, also uses 1 mole of HNO3. And then 1 mole of HNO3 has a mass of 63.02 grams. Okay. So grams of C7H8 cancel, moles of C7H8 cancel, moles of HNO3 cancel. We're left with HNO3. Okay, what does it come out to be? It comes out to be 376.14 grams. Okay, so what does that mean? That means in order to use up all of the C7H8, all 550 grams, I'm going to need 376.14 grams of HNO3 needed. But look, I only have 287 grams. So guess what? I don't have enough HNO3 to use up all the C7H8. So that means HNO3 is limiting reactant because not enough to use up all of C7H8. All right, got that part done. So I found the limiting reactant. Now that I found the limiting reactant, my goal was to get an actual yield over a theoretical yield. So now I would take the 287.3 grams of HNO3, and now I got to find a theoretical yield. So I'm going to change it into product. And I found out from the periodic table that it was 63.02 grams for every 1 mole of HNO3. That came from the periodic table. PT, woohoo! All right, and then I know that there's 1 mole of HNO3 for every 1 mole of C7H7NO2 that forms, also called p-nitrotoluene. And then I know that for every 1 mole of C7H7NO2, I'm going to find a mass of C7H7NO2 from the periodic table to be 137.15 grams. Okay, let's see what we get here. So I plugged in 287.3 divided by 63.02 times 137.15, and I get 625.25 grams of C7H7NO2. But what does that mean? Tell me, what does that mean? This is called a theoretical yield because it's saying if all of the nitric acid gets used up, this is how much, in theory, C7H7NO2 should come out. So I'm going to sneak up to this corner over here to do my percent yield. So I have my actual yield given in the problem, 601.1 grams. Actual yield of HNO3, C7H7NO2, divided by 625.25 grams, in theory, C7H7NO2. All right, times 100. My percent yield is 96.14% yield of C7H7NO2. Woohoo! Final answer. Okay, one more problem. This time we're given a balanced equation because we need it. It says if 1.85 grams of aluminum reacts, so this is reactant, given reactant, 312.45 grams of copper sulfate, given another reactant, ooh, two reactants, looks like a limiting reactant problem, and 512 grams of Cu forms, given product, so this is actual yield, all right, what is the percent yield? Find percent yield. Okay, given two reactants, I have to do a limiting reactant problem. So I'm going to pick one reactant. I'll pick 1.85 grams of aluminum. And I'm going to change aluminum into copper sulfate to see how much of that I need. So grams of aluminum, 26.98 for 1 mole. That came from the periodic table. All right, times 2 moles of aluminum for every 3 moles of CuSO4. Where did I get that? Coefficients, 2, 3, 2, 3, times 1 mole CuSO4 has a mass of 163.62. 163.62 grams of CuSO4. All right, so what do I find out here? I find out that 16.83 grams of CuSO4 is needed to use up all my aluminum. All right, so I go back to my given. I have 312.45 grams of CuSO4. So guess what? I have way more CuSO4 than I need. And so that means, so Al is Lr because there is way more CuSO4 than we need, than needed to use it all up, to use up the aluminum. Okay, next step. So I found out aluminum is limiting. Next step I need, because remember percent yield is actual over theoretical times 100. All right, percent yield. Okay, so right now I have actuals given in the problem, 512 grams. I need theoretical, so I use my limiting reactant, 1.85 grams of aluminum, and I change it into product, 26.98 grams aluminum. That's from the periodic table for every 1 mole of aluminum. All right, and then 2 moles of aluminum coefficient makes, let's see, I want to change it to copper, 3 moles of copper. Why did I pick copper? Because I have copper and aluminum sulfate. But the problem gives me an actual yield of copper, so that's why I picked copper. And then 1 mole of copper, where do I get this number? If you're thinking periodic table, you're right. 1 mole of copper weighs 63.55 grams. Okay, so I do the math here. Grams of aluminum cancel, moles of aluminum cancel, moles of copper cancel. I'm left with grams of copper. Grams of Cu, 6.54. 6.54. All right. So what does this mean? This is my theoretical yield because it's saying if all my limiting reactant gets used up, that's how much copper should come out. So now I take my actual yield, 5.12 grams of copper given here, right? Divided by my theoretical yield, 6.54 grams of copper, times 100. What do I find out? And I'm going to write it down here. I know it's messy, but hey, you can see it, and I'm writing in purple, so you can't go wrong. I find out that 78.29 is my percent yield of copper. Percent yield of copper in this reaction. So I thought I'd be able to make 6.54 grams. I only made 5.12 grams. So I divided 5.12 by 6.54 times 100. I find out I got 78.29% of what I could have gotten. All right, let's see. Review. Ooh, listen to Moltato. So you want to see what Moltato, why this is Moltato? So here's his eye. See it, see it, see it. Here's his nose. Yes. Here's his mouth. Oh, he's smiling. Oh, and here's his hands. Oh, there's one, there's one. Oh, look, it's Moltato. All right, you know what? I'm going to erase this in the nose because that makes it look like a creepy eye. But anyway, Moltato is very wise. And Moltato says use moles and the yield will follow. So what's a limiting reactant? A limiting reactant is the one that gets used up and controls the amount of product made. Excess is left over, so it did get to react. A limiting reactant helps us calculate a theoretical yield. We always have to go through moles and use coefficients when it's moles to moles. Mole to mole, use coefficients. Coefficients. All right, any yield has to be product. Remember, it says yield is asking about product. Percent is always part over total. Part is the actual yield that's given in the problem. Total yield is can be given in the problem, but if not, total comes from stoichiometry using the limiting reactant. All right, that was objective 9C all over again. Hopefully you learned it. Take care.